Hello everyone, welcome back to the channel. Today I've come here with a set of tricks of Python sets. So at first we'll see how we can create an empty set. So for creating an empty set, first you have to create a variable and then you can use the set function, which is the by default method. And now when you'll print the type of this variable, it will say that it is a set, and when you'll print this empty set, then you will see a empty set is getting printed. So in this way, you can create a empty set. Now, suppose when you have initial values already present, so then how you can create a set? Then for that, suppose I have a variable fruits and I have some fruits present initially. So you can store like this, like this. And when you'll print, now you'll see when you have initial values, you can create set like this. And when you have to create an empty set, you can create an empty set like this. Remember to use the curly braces because a set is stored inside the curly braces. Now you'll see some operations adding and removing an element into our set. So as we know, the set is an unordered structure. List means it is unordered, no indexes are present in set. So we can directly use the add method to add elements in our set. So I have added orange here. Directly I have written the name and then I'm printing fruits. And as you can see, when I'm printing fruits after adding, so initially in my fruits set, there was cherry, banana, and apple. And when I have added orange, so orange also gets added. Now, this was for adding a single element. When I have to add a single element. Now, when I want to add multiple elements together, so that how we can do it. So for adding multiple element, what we can do, we can use another method, that is an update method. So how we can use an update method? Simple. We'll write first our set name, then we'll write update parenthesis, and inside the parenthesis, in the square braces, we'll write our fruits names. Like suppose I want to add pear, then I want to add kiwi, and then I'll simply print my fruits. Now you will see kiwi and peer has been added, and because as I have said that sets are unordered, so the order of this list will be uh, not guaranteed, it could be anything. Now this was for addition. Now for remove, suppose when we want to remove it, so how we can remove it? So for removing elements, we can use two methods. One is the remove method, or we can use the discard method. So how we'll use that? So first you write the set name, then you will use the method remove, and in the remove you directly write the uh, name of your element which you want to remove. I want to remove banana, and then I'll just print fruits so that it could be visible to us. Now you will see that banana, at first when I printed fruits, then there was banana, but now when I have removed banana, so now there is no banana in our set. Okay, so I'll just comment this line out. Now For discard also, we'll do the same thing, but now instead of remove, we'll write discard over here. And now, because banana has already been removed, so we have to remove some other elements. Suppose, so now I want to discard kiwi. So now you will see that kiwi has been removed and only cherry, apple, pear, and orange has been left in our set. So this was how we can add single, multiple, and how we can remove using remove and discard methods. Now, how we can check membership. So for checking membership, we can use the membership operator in. So how we can do it? It is very simple. We have to just write the condition if, then suppose we want to check it for apple. So we'll write if apple in, then we'll write our set name. If apple in fruits, then print yes, apple is present. And now when I'll execute the code, so apple is present in our fruits. So that's why it is this print function is getting executed and it is printing yes, apple is present. Now, now there are some operations, set operations present in our set. So that operations are union, intersection, difference, and symmetric difference. So now how we will perform these things, union, intersection, difference, and symmetric difference. So for that, first of all, we have to take two sets. So I'll take one set 1 2 3, and then I'll take another set 2 as 3 4 and 5. Now for checking the union, first I'll create a variable union set. Now we have to just use this operator which you will find just above your enter key, and when you will print your union set, what will happen that all the elements all the elements present in our these two sets will get printed, but this 3 will get printed only one time. Okay, now you will see when I have executed the program, so 1 2 3 4 5 has been printed. Okay, so the union means that the combination of these two sets and the common elements will get printed only one time. Now for the intersection, so again for the intersection also we have to create a variable. So I'll create a variable intersection set, then in set 1, and then we have to use the ampersand, and in set 2, and then I have to print, and then I'll just simply print our variable intersection set. And now you will see the output that when we are doing the intersection, then only 3 is getting printed, means only the common element between our two sets are getting printed. Okay, so this was intersection for use, and this is the operator which is used for the intersection. This is ampersand. Now for the difference, so again for the difference I'll create a set, a variable difference set, and then you have to just, for the difference you have to just do it set 1 minus set 2, and you have to print the difference set. Now when I'll execute the program, what will happen that this 1 2 will only get print. Now you will see when I execute the program, only 1 2 get prints because we are doing the difference from set 1 to set 2. So what is happening, only the unique elements present in set 1 will get print, and else every element will not get printed. Suppose when I'll interchange it, means when I'll change it from set 2 minus set 1, so 4 5 will get printed, means then only the unique element present in set 2 will get printed, and any other element will not get printed. Okay, now the symmetric difference. So for the symmetric, I'll just create sy set, and then I'll just do it set one, and then we have to use this operator. So I don't look clearly the name of this operator, but you have to use this operator. Now, when I'll execute the code, you will see the common elements has not been printed, and other than the common elements, all the elements are getting printed. So this is the symmetric difference for you guys. And in this way, you will, when we have to print symmetric difference of two sets, so we will just use this operator and it will get printed. Now, we can convert other data types to sets also. That is how, suppose I have a list and I have to convert that list into a set. So I'll just simply pass this variable in which I have stored my list, my underscore list, into the set function. And after that, when I'll print unique set, so it has been converted to a set. Now, as we know, set contains only unique elements. So suppose I have double five, I have put double five in my list, and when I'm execute the program, so you will see one five has been removed and only one five has been kept here. So in this way, you can convert from other data types to sets also. Now, iterating over sets. So for iterating over sets, we can use the for loop. So how we'll do it? We'll just simply write for fruit in fruits print fruit. So in this way, you can see cherry, apple, pear, orange has been printed. Now, because sets are unordered, so that the order of the iteration is not guaranteed. It could be anything. I mean, suppose now it is printing like this, but if there are many big datas, so because sets are unordered, so it the order like this at first place cherry has been printed, then apple, then pear, orange. It is not guaranteed. It could change also. Okay. Now we'll move to the next thing, that is the set comprehension. That how we can do the comprehension in the sets. So I'll just show you an example of printing squares, and in one line we'll just print squares from 1 to 5. So how we can do it? So first of all, we want to print the squares, so we did this x, then we have used the operator, then we have entered 2 here so that it will print the square of every numbers. Now we'll use the loop. So for x in range starting from 1 going till 5, so we'll write 6 here, and then we have to print our square variable also. And now you will see the squares of 1, 2, 3, 4, and 5 has been printed. So in this way, you can just print the squares, or you can do many more things in just one line using this set comprehension. Now we'll see the concept of frozen sets. Now what is frozen set? So for frozen set, I'll just create a variable and I'll store 1, 2, 3, 4 in it. Now I'll create a variable name frozen set. And then I'll use the frozen set function and I'll pass this set 3 in it, and then I'll print this frozen set. So now you'll see when we'll convert a set into a frozen set, then when you'll print that particular frozen set, so it will print like this. First your set will be get printed, and then before the set, a frozen set name will get printed so that it will be known that it is a frozen set. Now, what is the benefit to create a frozen set? So the benefit of creating a frozen set is that suppose we want a set in which no manipulation could be happen. So suppose when I'll try to add a element, suppose I want to add 5 in this frozen set. So I have written this frozen set over here and I'm using the add method. Now when I press enter, it will throw an attribute error that frozen set object has no attribute add. Yeah, that is because we create frozen set because when we don't want that in our set any manipulation could be performed, we want a fixed set, then we use frozen set. Now we can again we can do the set comprehension based on conditions. So suppose when I want to print even numbers from 1 to 10, so we'll use the curly braces. In the curly braces, I want to print x, so I have written x. Then I'll iterate over each x. So for that, I have used a for loop. So for x in range 1 to 11, and then after that, I'll just give the condition to check for the even number. So we know the condition for checking even numbers. The remainder should be 0, and then I'll print this even number over here. And now you will see all the even numbers present between 1 to 10 has been get printed. Now, at last, the last trick is to remove all the elements from a set by using a single method, and that method name is clear. So first of all, I'll print fruits for you. So you can see in our fruits set there are 4 elements present. Now when I'll use the clear method, clear is the method which just clears all the elements present in our set and makes the set empty. And after that, when I'll print fruits, you will see first there was 4 elements, and then when I have used clear, then and after that when I have print fruits, then only an empty set is getting printed. Okay, thanks for watching the video. This was all for this set tricks. See you in the next video.